Hello, friends. This is a podcast to get us started on section 4.4 in the Algebra 2 book. As promised in the previous podcast, we are now going to start factoring quadratic equations where we have an a term other than 1. And this makes matters a little more complicated. You can see that now we don't have to just consider an m and an n, combinations that multiply to 7 in this case, but we also have to consider K's and L's, that is combinations that multiply to this. So this first example that you were asked to think about in the last podcast is pretty straightforward because there's only one way to multiply together and get positive 2, and there's only one way to multiply together and get positive 7. And you can see that's just what they've done. It's got to be 2 times 1. That's the only way we could do it. And it's got to be 1 times 7. And there's only two ways to arrange this. So I can just start out by putting the two x's right here at the beginning and the x's in this. And I know that's the only way that can happen. And then I just try the other combinations. All right, so I try the 1 with the 2x and the 7 with the 1x, or the other way around. And to find out which one is correct, I have to FOIL both of these. So when I FOIL them, what I come out with in this case is a 15x in the middle. All right, but that's not what I want. I want a 9x. But when I multiply this one out, I do in fact get the 9x that I need. So that tells me that this is the factored form of 2x squared plus 9x plus 7. Now, of course, all the problems are going to get gradually more difficult just by changing the sign, even though the 3 here and the negative 2 are prime numbers. Just adding the negative means there's 2 more possibilities for the m's and n's. 3 is still the same. It's got to be a positive 3 times a positive 1. And it could be negative, it's true, but since they're going to be the first term in each of these binomials, we're just going to leave these all the same and just lock in the 3 and the 1. So this one still isn't too bad, but I do have 4 possibilities here for the m's and n's. So again, I'm going to put every one of these in here. You can see, and actually I'll just drag down here. And then you multiply every one out. And I look for the one that gives me what I started with. So in this case, I want a negative 1 for my b term right here. And there it is. So that means that this one is the correct factorization. As you do more and more of these, it'll become more intuitive for you. In other words, by intuitive, I mean you'll just start to see relationships between certain numbers. So again, the key here is practice. So when you get your lesson 4.4 practice sheet, you want to do every single problem. Even though you quote unquote get it, you need to practice over and over just to develop good habits. And obviously, as you can see in this problem, you need to pay attention to the signs and really focus all the way through because there's a lot of places to make a silly little mistake. So let's try practicing these. You guys do them right now, and we'll go over them in class. Next up, we've got those special cases that we started talking about before break. We have the difference of squares, all right, and we said the giveaway on the difference of squares is that what they ask you to factor is a binomial, not a trinomial. Notice there's just an x squared term and a constant. There's no x term in the middle. So this should be immediate indication I'm probably looking at difference of squares. But to be sure, what's got to be true? Well, the a term has to be a perfect square, and 16 is. That's 4 squared. And the c term has to be a perfect square, and it is. 36 is 6 squared. And the sign has to be negative. All right, so these 3 things have to be true in order for it to be a difference of squares. So it's one more thing to remember, but here's the good news. Once I know this, I know that the answer is going to be the square root of the first term. So in this case, the square root of 16x squared is 4x. That's going to go both here. And the second term is going to be the square root of the c. So in this case, 6. And so I just have 4x plus 6 times 4x minus 6. And that's my difference of squares. We'll pick up with perfect square trinomials in the next podcast.